Okie dokie, so today I'm doing an example of the first derivative test and how to kind of do that with a sign diagram. So this is the function I'm going to be using. F of x equals 1 half x minus sine x. So to take the derivative of this, I'm going to use the power of rule. So the 1's going to come down from the x, and the power is going to be 0 on the x. That's just going to be 1 half. And then the negative 1 follows the sign down, so negative 1 times sine, and that's going to be cosine x. So now I have my first derivatives. I'm going to find critical numbers. So I'm going to set f prime of x equal to 0. So 0 equals f prime of x, which equals 1 half minus cosine x. So I'm just going to move the cosine to the other side. So I get cosine x equals 1 half. And if we draw the unit circle, we will know that this length is 1 half here and 1 half here. It's actually negative 1 half there. Oh, because it's 5/3. Right there. It's 1 half, and this would be this would be pi over 3, and this would be 5 pi over 3. And so those are going to be my two locations here on my graph. So I'm going to have right here, I'm going to have pi over 3, and over here I'm going to have 5 pi over 3. So now I want to test numbers that will satisfy this. So here I'm really going to test let's see, pi over 6, right? And then over here I'm going to test pi, because that's an easy number. And then here I will test 11 pi over 6. So that would be 11 pi over 6 would be here. Pi over 6 is going to be right there on the unit circle. I know it's pretty tiny. We should be able to do this in our head. So x equals pi over 3 comma 5 pi over 3. And so these are our critical numbers. So now I have my points to test as well. So f prime of pi over 6, that's going to equal 1 half minus the cosine of pi over 6. And if we go to our unit circle, the cosine of pi over 6 is going to be root 3 over 2 minus 1 half. And so this number, if we did the math, would be less than 0. So since that is less than 0, the slope is going to be negative. Then we're going to test it at pi. And so here at pi, it's going to be negative 1. So for f prime of pi, we're going to have 1 half minus cosine pi. And so that's going to be 1 minus 1 half. That becomes positive. So we get 3 halves, which is greater than 0. So that's greater than 0. So that's positive. Then, last one, we're going to test f prime of 11 pi over 6. So once again, 1 half minus cosine pi over 6, 11 pi over 6. The answer is still, because the cosine is the x direction, this cosine is still root 3 over 2. It's going to be subtracted from 1 half. That's less than 0. So that's less than 0. So that's negative. So from this, we can know that we have a relative maximum at 5 pi at x equals 5 pi over 3. And we have a relative minimum at x equals pi over 3. And then the function is increasing. And I'm going to limit the interval from 0 to 2 pi as well. So I'm just going to limit my interval. So I'm increasing from 0 to pi over 3. Oh goodness, almost messed up. We'll go decreasing first. So decreasing from 0 to pi over 3. Function goes down to pi over 3. Close that parenthesis, union. And then it starts decreasing again at 5 pi over 3 to 2 pi, because that's my interval. And then the function would be increasing from the interval of pi over 3 to 5 pi over 3. And so that's kind of the breakdown of what we're to do during when you're doing the side diagram for a first derivative, and kind of all the things you can find where the function is increasing and decreasing, and where it changes whether it's increasing or decreasing in the critical numbers. And I hope that was helpful.